representation of data. So the first thing we'll be looking at is key features of data. Now this is like sort of the different characteristics of data that we use to compare different data sets. So the first will be central tendency. This is also known as average. And there are three different types of average. The first is the mode or modal class. This is the mode is most frequently occurring value or result. And the modal class is interval with highest frequency density. So for example, if you had a bit of data of 0x if you had data along the lines of this, then you would divide your frequency. This is your frequency, and frequency over class width. So let's see over class width. So for this one we'd have 10 over 10 equal to 1, 10 over 5, which is equal to 2, and 12 over 15, and we know that's going to be less than 1. So this one, the second class, class 10 to 15, is our modal class because it has the highest frequency density. And say for mode, if you had favourite colours, 10 said red, 3 said green, 15 said blue. Blue is your mode. And if it isn't obvious, the mode is the most popular value or choice, not the actual number or frequency of that value there is. The second measure of central tendency is the median, also known as your middle mark. So there are kind of two possibilities with your data here. You could have, and so with ungrouped data first, there could be an odd total number of data values or an even number of data values. So if we do odd, say, let's just do some numbers. 1, 3, 4, 6, 8, 12, 17. We've got 7 total. So we go from the ends, count along, and find the middle. So 1, 2 from the middle, 3 from the middle, 6 is our median. But then if we had even number of things, so let's say 1, 3, 4, 6, 8, 12, 17, 21, we've got a problem. We can do this, but we've got a problem. We don't have a middle number technically. So what we do is we take these ones, add them together, then divide by 2, will give us 7. 7 is our median. Now if we had grouped data, I'll just say that for ungrouped data, if you notice, we have 7 total values, and the median was at the 4th number, and here we had 8 total values, and the median was at the 4.5th number, if you like. So then we can generalize this formula as the median in ungrouped data is at n plus 1 over 2 value number of data points is your n. And we can see that works. 8 plus 1 over 2 is 4.5. 7 plus 1 over 2 is 4. But for grouped data, always estimate mean to be at n over 2th value. So say we had this one here, we had this up here. We'd say, okay, there is a total of 32. So the median is at the 16th number. We have a look, 10 here, not enough. Okay, it's going to be somewhere in here. So what we'll do is, okay, we've already got 10, we need another 6, so we'll go 6 over this 10 here, multiply by the class width of, add it to 10. So that's going to be 13. We estimate this to be at, our median to be 13. And now the third measure of central tendency is the mean. This is the most commonly understood average. This is when you sum of all values divided by number of values. You may see this as sum of x over n, and you write it as x bar. That is your symbol for mean. So if we take a look at this example here, 1, 3, 4, 6, 8, 12, 17, what we'd do is x bar equals 1 plus 3 plus 4 plus 6 plus 8 plus 12 plus 17. Over 7. That's going to be equal to 51 over 7, so 7.292 3SF. And then also, if you get it in a table of x and then your frequency, and you say 1, 2, 3, 5, sorry, we're putting a 2 here, 1, 4, 0, 5, 7. Your mean would be, you have to use, it's fairly intuitive, you'd have to kind of count each number, however many repeats the table tells you to. So you'd have to count 2 1s, 1 2, 5 3s, 0 4s, and 7 5s, and then divide it by the sum of the frequencies. And that's given by the formula sum of x times f over sum of f. So we do 1 times 2 plus 2 times 1 plus 3 times 5, 4 times 0 plus 5 times 7 over 2 plus 1 plus 5 plus 7. That's equal to 3.6. So that's the 3 measures of central tendency. And which one should you use? Well, there's a few advantages for each and a few disadvantages. So if we have a think about it, so the mode, well, imagine you are a car company and you want to know which model of car that you should be producing more, because not all cars sell the same. So you'd probably look at the cars you're selling, you'd split them up into the model, and you'd see which one's the most popular, i.e. which one is the mode. So that's one example of what's good about the mode. It tells you the most popular. And it can be used for all qualitative data. Now that word qualitative just means like things that aren't given in numerical terms. So things like favourite colour, or like we said earlier, car model, or things like that. And also the mode is unaffected by extreme values. However, the disadvantage of it would be that it ignores most values, and sometimes, while in small samples of quantitative data, the mode doesn't tell you really anything, and it can actually be misleading. But the mean, now this is actually, well, when people say average, they probably mean the mean. It's the most commonly understood average. And it's usually used in further calculations, and it takes into account all values. But it does mean you need to know every value. Can't calculate the mean without knowing all the values, and it is affected by extreme values. Now the median, you don't need to know all values, and it's mostly unaffected by extreme values, but it ignores most values, which can be a disadvantage. Now we can talk about the shape or distribution or skewedness of data. That's the second feature, the shape. Now you can have what's called positive skewedness. And if we did your frequency over here, and then a progression of values of your data values along the x-axis, it'd look like that. Your tail is on the right. And this means, what this is saying is, a few high values skew the mean upwards, but most are low. And so that means your mode is going to be smaller than the median, which is going to be smaller than the mean, because the mean is most affected by extreme values. On the other hand, you can have negative skewedness. Do the same thing, it's going to have an opposite. It's going to have the tail on the left. And this is saying a few low values skew the mean downwards. So the mean is the smallest because it's getting skewed the most, which is smaller than the median, which is smaller than the mode. You can also have a symmetrical data set. This is also known as normally distributed, and it said that the mean is equal to the median, which is equal to the mode. Then you can also have bimodal or multimodal.